Let's have a look at this question. It has to do with calculus, derivative, and tangent. So we are given an equation of a function. What kind of function is that? Cubic function. How do I know? Because it has x to the power of 3. Okay, so we are given the function. What do we need to do? We have to find, and here we have a description, f, and then we have this dash here, an x. What does that mean? That is a derivative of our function f. So we have to derive it. How do we derive any function? How do we create derivative? We identify each element, and each element is done separately. Now, let's start with the easiest. When you have a number with no x beside it, that value goes to 0. So basically, it disappears. Then the next one, 2x to the power of 2. So here we are applying the formula. And how does that formula works? When I have x taken to power and I'm trying to create derivative of that item, that power goes in front of the x, and then power is decreased by 1. So minus 1. Now, what happens in the number, if I have any number standing in front of the x, that number just crosses over. So that means that 2 will cross over, then it will be multiplied by the power. Power is 2, followed by my x, and then my power minus 1. So that means 2 multiplied by 2 will be 4, x, and 2 minus 1 will be 1, so power of 1. So that is my next element, and the last one, x to the power of 3. Here we don't have a number in front of it, so again, power goes in front of the x, followed by x, and then power minus 1. So that means 3x to the power of 2. Now let's put that derivative together. So first I have my cubic element, so 3x to the power of 2, then my 4x. Now, unlike what we said, 5 disappeared. Okay, and then the next part, we have to show that. What does that mean? So when you have, again, here in the bracket, normally you have x, but when in that bracket you have a number, that basically is telling you, take x and replace that x with that number, in this case is 1. And they are saying derivative, not the function, so the one we've created. So we are taking our derivative and we are saying we're going to replace x with 1. So that means it will be 3 multiplied, and instead of x, we put 1 to the power of 2 plus 4, and again multiply by x, which is 1. And we put that in the calculator, press equal, and indeed we are getting 7. Now, they are saying hence. What does that word mean? With the knowledge you just acquired. So we acquired the knowledge of the derivative, and as well, in that derivative, when x is 1, y is 7. And then we have our derivative. So with that knowledge, we have to find the equation of a tangent to the function f at x equal 1. So what does that mean? So I have my function, and somewhere, now I'm just doing that for the purpose of explaining. I don't know how the graph 100% will look like. So let's say somewhere here I have my x equal 1. So at this point, they are saying, what will be the equation if I draw a tangent, meaning just a straight line? Tangent is just a fancy word for a straight line that will be touching that curve. It's not going to cut it, it's just going to touch it at that particular point. Okay, so equation of a straight line. How do we write an equation? We have a formula in our table in coordinate geometry. So we write down our y minus y1 equal m multiplied by x minus x1. So what do we need in order to use this formula? We need two things. We need the point, because x1 and y1 are coordinates of a point on that line. And then second thing, m stands for slope. So we need the slope of that tangent and we need a point. Now, do we have a point here? Well, what we have is that point that belongs to the tangent, it as well belongs to the function, isn't it? So I know that point here have an x equal 1, and I need to have y. So how do I find y so that I can use it in this equation of the tangent? Well, I go to my function, my original function, I put 1 in place of x, and therefore I find y. Why do we do that? Because let's not forget, here I'm just going to write our function f of x. In your equation of every function, the reason why you have letters x and y is because they represent the coordinates of every point on that function. So when we are given a point, we can always replace x and y with those numbers, and it will make that equation true, meaning both sides of the equation will be the same. So in this case, I have x is 1, but I am looking for y so that I can use that point in my tangent. Okay, so let's replace x with 1. So that will be 1 to the power of 3 plus 2 multiplied by 1 to the power of 2 minus 5. So we take all of that, we put it in the calculator, and we get the value of minus 2. So that is our y coordinates. So in my equation, x1 and y1 will be 1 and minus 2. Now, what about the slope? So again, here we are using that knowledge that we are having, that the value of the slope of the tangent of the function, because they are the same, is the same as the value of derivative at that point. So that's the reason why they were pointing hence, because we know the value of derivative when x is 1. We just calculated that in that previous part is 7. So we understand that the slope here will be 7. So now we can replace, let's just remove this here. We can replace those letters with numbers. So it will be y minus the y coordinate minus 2. Again, don't get caught, is double minus. And then our slope 7, bracket x minus x1 is 1. So what do we do? Well, the next thing we have to multiply the bracket. So we can change that 2 minuses to a plus. 7 multiplied by x is 7x. 7 multiplied by minus 1 is minus 7. Now here we don't have really terms and condition. So how do we write our equation? Well, we can have it in the form y equal mx plus c, meaning y on its own on one side and the rest on the other side. So the last thing we need to do, move that 2 to the other side, therefore change the sign. So from positive plus 2 will become negative minus 2. And then we can add those two values, minus 7, minus 2, together. That will be minus 9. And there it is, our equation of the tangent of that straight line.